Sorry. The network knocked me out, so I was battling with it. I'm back now. Let's just finish this thing. Yes. So let's go to the second. So you see the interpretation now. Anyway, we'll still talk much about that. Let's go to the second example. The second example is about odds ratio. Odds ratio. We still come back to interpretation later. Look at this example. Of 200 patients treated in the hospital, 50 have lung cancer. Of these patients, 45 are smokers. Of the remaining 150 patients, 60 are smokers. What is the odds ratio? Look at it by this sentence. Of 200 patients treated in a hospital, 50 have lung cancer. Of these patients, 45 are smokers. Of the remaining 150 patients, 60 are not smokers. What type of study design is this? What is your mood and answer? Olamide. Olamide, where is she? He's not there. Okay, Amira Idris. What type of study design? You see, some people. Okay, no worry. Say I call you now, you are not answering. Don't come to me. Oh.
Hello, sir.
Yeah.
Oh, yes. I
What
think
type
it's
of study design is this?
I think it's a retrospective study.
Don't use the word retrospective. Use another word. I don't like the word prospective, retrospective, because there are many things that are too many things that are like that. You understand me now? It's just like when they make mention of a surname. There are many people that are bearing the surname. If they want to be particular, say which of the Idris are you talking about? They want to say Amira and him. So the retrospective, prospective, those ones they are more like general and generic. But there are many things under it. Go to specific. This is a case control study in the sense that they've told you 200 patients. They already told you patient. They said, now say, okay, out of this patient, so number one, smoker. That's why they already known that these people are patient. They have this disease before they thought of asking them, did you smoke before?
Hello?
Yes.
Okay, so I had a network glitch.
So we
I
have
think it
already
should be
started talking. Case control. Case
Yes.
control. I say it's a case control because
Mm.
here now, they start with the disease. They say 200 patients. They now say, oh, so number among them have smoked before. You know,
Yes, sir.
they already talk about the disease before they now ask questions about whether they smoke before. Unlike the other one where they say, oh, these people were smoker. They were follow up. They follow them after many years. So develop. You know that one is a core study. But this one, when they say talk about disease, now say, oh, this is smoke. That shows that they've known the disease before they say whether the person smoke or not. That is case control. Now,
Yes, sir.
look at the by the explanation now, one can actually tabulate. You see, of 200 patients treated in the hospital, the total is 200. That's the grand total. And I see 50 have lung cancer. So look at total lung cancer, 15. Can you see? And I see of these patients, 45 are smokers. Of the 50 that have lung cancer, 45 smoke. That's how you put it. So if 45 is yes now, smoke, lung cancer, then the remaining one, no smoking, will be 50 minus 45. Yes, minus 5. 45, give it 5. They now said Of the remaining 150, you know, the 50 have lung cancer. The remaining 150, they don't have lung cancer. Of the remaining 150, you know that's, even if they don't even tell you 150, you know that out of 250 have lung cancer, the remaining will be 150. Now say 60 are smoker. So if 60 are smoker, you now know, okay, 150 minus 60, the remaining one will be 90. So nobody will give you question and I put the table there. It's true that I will draw. The first question will say, draw a 2x2 contingency table to show the scenario. Then that's the first question. That one has its own mark. Now, let's look at, if you remember the logic behind odd ratio, we say odd is risk over 1 minus risk. So let's look at the people that have this one. Is it Cathy or whatever? You are disturbing class. I can't even see your name. Now, 50 people that have lung cancer. How do you know what is the odds of smoking? So for you to calculate or look at it from the concept of risk, let's say you are thinking of the risk of smoking among the people that have lung cancer. We know that you are not calculating risk, but you want to, you can calculate odds through the risk. So what is the risk? If you say, what is the risk of smoking among those people that have lung cancer now? Is what over what? Who will say it? The risk of smoking is what? What over what? No question, nobody. The risk of smoking among the 50 people that have lung cancer. The risk of smoking will be 45 over 50. 50 people. And out of the 50, they say 45 have lung cancer. The risk of smoking will be 45 over 50. But what is the risk of not smoking? Who will say it? What is the, I've said one now. What is the risk of not smoking?
5 over 50.
5 over 50.
5 over 50.
5 over 50. You are right. 5 over 50. So what is the odds of smoking now? The risk of smoking is 45 over 50. The risk of not smoking is 5 over 50. What is the odds of smoking? It's a classroom. It's an interactive classroom. Nobody. Olamide. Olamide.
Yes, I'm hearing you, sir.
And what is the odds? Are you following? The risk of smoking is 45 over 50. Over 50. The risk of not smoking, which is 1 minus risk of smoking, is 5 over 50. What is the odds of smoking? So I've already told you that odds is risk over 1 minus risk. Odds is the probability of event over probability of the event not happening. So I don't know why people cannot. So nobody. Eh? So. Don't give me, just don't say 9. Just tell me from what we have said now. We say the risk of smoking is 45 over 50. The risk of not smoking is 5 over 50. And I say, what is the odds? Is what over what now? That's what I want to hear. Don't just eh? What is it?
The odd is the risk over 1 minus the risk.
What? How do you from what? What is it?
The risk is 45 over 50, which is 0.9. Then 1 minus 0.9 is 1. So 0.9 over 0.1 is 9.
Yes. Well, you are right. But what I want you to say from we say the risk of smoking is 44/50, of not smoking is 5/50. The odd will be 44/50, everything over 5/50. You understand? 44/50, then over 5/50. And by the time you change something, 50 will cancel 50, it will be 44/5. So you get the 9 you are talking about. Yes, 44/5 with 9. Does it make sense now? So it's the logic, it's the logic. It's the same thing with the among the people that do not have lung cancer. What is the odds of smoking? It's 60/90. Because it's going to be 60/150 divided by 90/150. At the end of the day, 150 will cancel 150, it's going to be 60/90. So that the whole amount of smoking among the people that have lung cancer is 44/5. The odds of smoking among the people that don't have lung cancer is 60/90. So what is the odds ratio? It's going to be 45/5 divided by 60/90. It will become 45/5 times 90/60. So that's what you have up here. A 45 over times 19/60 times 5. So is when you work it. So that is why if you look at sorry, something covering my sorry, I just stopped sharing because so if you look at 45 is A, Abi. What of 60?
B.
If you use A, B, C, D, A is 45. What of B?
60.
60. What of C?
5.
5. D is 9. So you see, if you look at our calculation now, 45 times 90/60 times 5 is 45 is A, D is 90. That's why AD, look at odd ratio AD over B is the 16. C is the 5 all over BC. So from that, you know that just come and say odd ratio is AD over BC. The cost, call it cost product. If there's a slide, I will look at it. Cross product. Odd ratio is AD divided by BC. So you cram that, but that's the logic behind it. I don't like cramming. So now there's something. If you look at it for the two scenarios, the first scenario was to demonstrate relative risk, the second one, odd ratio. But if you look at it, we also calculate odd ratio for the other one. Here also, we can calculate relative risk for this one. Look at the value of odd ratio and relative risk. What to use to explain something. So if you look at the computer, can you see the first one is, if you look at the odd ratio is 30.5. The corresponding relative risk is 80.14. Look at when you run it, that first one is the odd ratio, 30.5. Then 8.143, that's the corresponding relative risk. Look at the confidence interval. So it does not cross 1 also. It's from 5.067 to 35.970. That is, the odd ratio in the sample you did is 30.5. But in the population, the value will range between will be anything between 5.067 and 35.970. Now, let's look at the interpretation of this odd ratio and relative risk. If relative risk or odd ratio is close to 1, there's no association between exposure and disease. In fact, if it is 1, it means there's no association. The reason means that you have divided two things. You are dividing two risks or two odds. If you divide two things of the same value, it give you 1. 50 over 50 is 1. 1 million over 1 million is 1. 1 over 1 is 1. 10 over 10 is 1. Anything you divide by itself is 1. So if the numerator and denominator are the same, 1. So if your odds ratio or relative risk is 1, it means that the two risks are the same. There's no association between the risk and exposure. This in both what you call the exposure group and non exposure, they have the same risk. That shows that the exposure is not doing anything, it's not related to the disease. So relative risk or odds ratios of 1, I mean there's no association. Indicate if relative risk or odds ratio is greater than 1 now, a positive association between the exposure and the disease of. So if the relative risk or odds ratio is greater than 1, it means that the numerator is greater than the denominator. It shows that that factor, those ones that are exposed to the factor, they are more likely to have the disease more than the one that is not exposed. So if it's greater than 1 and maybe 3, it means that it's 3 times. If it's 1.5, it means that 1.5 times. The relative risk or odds ratio less than 1 means the exposure is associated with the less disease and protective. What it means is that if you divide the numerator and denominator and the result is 0 point something, it means that ab initio, the numerator is smaller than the denominator for you to have the 0 point something. And you know that the value for the exposure is the numerator. The unexposed is the denominator. If the denominator is now higher, the people that are not exposed, they have more that disease than the people that are exposed. That shows that their exposure is preventing the disease. So when relative risk is less than 1, which is 0 point something, it may mean that it's protective. The relative risk or odds ratio often reported as a single number followed by a confidence interval in bracket or parentheses. The range of confidence interval include 1. If the range of confidence interval include 1, then the result is not statistically significant because you know that when the relative risk is 1, it means there's no association. So if you give a range of value, and I say, oh, in the population, this is the range of value. Maybe you start from 0.7 something over, then cross to 3 point something. In as much as you start from 0, before you can go anything after 1, it must cross 1 now. It's a range. So that's so that in the range, 1 is one of them, and this one is one of them. It means there's no association. So can you see the interpretation of relative risk and odds ratio, the confidence interval now, is quite different from that of difference between means. The confidence interval of difference between means, it is when it crosses 0. You know when you are minusing two things, if two things are the same, you minus it gives you 0. So that logic for mean is minus. But in relative and relative is division. The relationship we are looking at here is not subtraction, it's division. You know, for that one, for the mean, you subtract one mean for the other, from the other. If the two means are the same, if you subtract, it gives you 0. That's why if it is 0, that means that there's no even difference in the mean before happening. That one, if the confidence interval includes 0, it means that there's no significance. But that is for me. Then when I talk about odds ratio relative risk, because it's about division, it is when you divide two things of the same value that give you 1. So the logic there, the factor there, the reference value here is 1. So when the confidence interval include 1 in its range, it's not significant. So look at different scenario that can come. Look at it. Look at 1 now. Look at that vertical line 1. So onto the left side, value less than 1. To the right side, value greater than 1. So significant if the confidence interval ranges from, if the value you get is 0 point something, it's less than 1. And the confidence interval is, of course, you know, the confidence interval, the value will be, the range of value will be, the lower value will be less than the value you calculated. The higher value will be higher than the value you calculated. So if the ab initio, the odds ratio or relative risk is less than 1. And the confidence interval also less than 1. It means that it's significant because the range of value has not crossed 1. The only thing is that the exposure is protective. But look at this second scenario. The value is still less than 1, but the confidence interval, the lower value is less than 1. The upper value is greater than 1. That's crossed to this side. It's not significant because the range of value, the confidence interval has included 1. The third scenario, the odd ratio is greater than 1, but the range of value confidence interval is ranging from -1 to anything after 1. It has crossed 1. It's not significant. The last scenario, the confidence in the relative risk is greater than 1, and both the lower and the upper value of the confidence interval are greater than 1. It means it's significant. The here is telling you that the exposure is causing the disease. So there's some other thing. I feel that there's some other thing I wanted to explain. I don't think you understand it now because I'm sure some people are already sleeping. Before so, you're already sleeping, right? Amanda?
Yes, sir.
I'm not sleeping.
In the next lecture, I will complete it. There's some concepts I want to explain here concerning it. Will take us back to some of those slides. But if it's already late, I'm sure some people they don't understand what I'm saying again. Or should we continue? Captain, should we continue? Amanda, you wanted to talk?
No.
You continue.
I don't know.
No.
Okay. I've already said no. I just want to. Let's stop here. You wait.
Explaining the significant and non-significant going down if the value is less than 1.
I don't. What did you say? Repeat again.
No. Why are the significant and non-significant going down if the value is less than 1?
If the value is less than 1, it's going down. I don't understand because is it this slide you are asking a question about?
Yes.
Okay. Okay. And what is okay? Significant. Well, I think the value, this arrow is just pointing to the value of the direction of the value of the odd ratio. See, to the left is less than 1. To the right is greater than 1. So the two middle ones, they are not significant because they cross 1. The other one to the first and the last one, they are significant. But in opposite direction. I say this one to the left here is significant. But you remember, the odd ratio is less than or relatively less than 1. And it's significant. It means that exposure is protective. That thing you think is causing the disease is actually preventing it. But this last one is significant, it's greater than 1. It means that factor is causing the disease. So this number 2 and number 3, even though number 2 is saying that the odd ratio is less than 1, it will mean that the thing is protective. It will mean that it's protective, but because the confidence interval has included 1, it's not significant. The same thing with third one. We'll have said that, oh, the odd ratio is greater than 1. Means that, oh, it's causing the disease. But the confidence interval crosses 1. It's not significant. So this picture just shows you 4 possible scenarios that can occur. Ekere, Kokone, any question?
Thank you, sir.
Yo, okay, thank you, Frank. Thank you, welcome. Any question? Okay, Ekere. Okay. If there's no other
Yes,
question.
sir.
Any question?
Mine
Okay.
is just a request. So it's just a request, not question.
Okay.
I don't know if you can have this note early so that we'll begin to read because my brain don't process to start sleeping before this lecture starts. So I need to start reading so that at least I can, catch up. If you
You
can
have
drop
not
the
been
note
reading
with us.
before. Which, okay, the note.
Yes, if we
The
can have it on time
I
for
will
this
send.
very.
Okay, the last something I've not sent the note to you. The last one we did, right? I will send. I will send
And this
together.
one too.
I will send them.
Thank you, sir. Thank you, sir.
Okay. Any other question? So call it a day. So maybe last until
Good night.
January. Yes. You have question?
No, sir.